Hey, if you're new here, this is Chandan and you are watching the learning field. Okay, so today in this video we are going to discuss the one session on the practice questions of ordinary differential equations, which we are already started, and there are some questions we already discussed in these sessions of practice ODE session. Okay, so this is another lecture on practice ODE session, and in this lecture we are dedicated to solve the questions from 30th November, okay, 2020, the CSIR NET paper from 30th November 2020, the ODE sessions. Okay, so the first question is, the first question says that let f from R to R be locally ellipsis function. Consider the system of the ODE is given by x dot equal to, the question is given x1 dot, this is equal to sine of exponential x2, and x2 dot, this is equal to f of x1 x2. Okay, and given that with the initial conditions, the initial conditions is x1 0, x2 0, this is equal to 1 1. This is the initial conditions. Then which of the following statements are true? Okay, there are 4 options in the questions. So since this is based on ellipsis conditions, therefore here we apply the Picard's theorem for existence and uniqueness. Okay, so the result is here, which is necessary to solve this question. For any IVP, suppose y dash equal to fxy, this is the IVP, where y at x0, this is equal to y0 is the initial condition. If f is continuous, if f is continuous in a rectangle, suppose R is a rectangle, suppose R, such that mod of x minus x0 less equal to a, mod of y minus y0 less equal to b. This is the rectangle and satisfying ellipsis condition, on R, then there exists unique solution. Y equal to yx. Okay, on the interval I, this is equal to mod of x minus x0 less equal to h of the IVP. Okay, where h equal to minimum of a comma b by m equal to maximum of mod of fxy or fx. Okay, in R. Okay, so this is the theorem. So if f satisfying the ellipsis condition, what is the ellipsis condition here on y? Okay, so mod of f x y1 minus f of x y2, this is less equal to k into mod of y1 minus y2. This is the ellipsis condition, and this k is called ellipsis constant. Okay, so this is the Picard's theorem for uniqueness of solution. Okay, so here the question is already says that f is locally ellipsis function on the interval. Okay, so locally ellipsis satisfied, that means there exists unique solution on that interval or on that boundary or on that local. The question says that locally ellipsis function, that means on a neighborhood of a point, this satisfies the ellipsis condition. That means there must exist an unique solution in that neighborhood of that point. Okay, so that means the here option A, it says that there is at most one local solution, so unique solution means at most and at least. Okay, so there exists at most one local solution at time 0. Okay, and So this is the clearly correct option. A is correct option. B says that there always exists a global solution of the defined in 0 infinity, but this cannot be true, okay, because in the question the ellipsis condition satisfied only at a neighborhood of a point, okay. So that means this is not correct option, so B is not true. As option C says that there might not any solution around the time 0, okay, but the initial conditions already defined. That means initial conditions means this solution is defined at the time t equal to 0, okay. This is already given in the question, okay. C is also incorrect, and D option says that there exists at least one solution around the time 0, okay. So this is also correct option. Since this is unique solution, that means this is at most and at least at the point, local point of that neighborhood, okay. So this is the answer of the question. Now go to the next question. The next question says that consider the differential equation. What is the differential equation? X square y double dash minus 2x into x plus 1 y dash plus 2 into x plus 1 into y, this is equal to 0. If a polynomial is a solution, then the degree of the polynomial is equal to, okay. So clearly see, this is first we have to identify this differential equation. This is what type of equation? This is second order ODE with variable coefficient, okay. Second order differential equation with variable coefficient, which is the standard form d2y dx2 plus p dy dx plus q dy, this is equal to r, okay. Where this r, if r equal to 0, then this is homogeneous, and if r non-zero, then this is inhomogeneous or non-homogeneous, okay. And p, q and r are the continuous functions of x only, okay. P, q, r are continuous functions of x only, okay. And here since r equal to 0, now we can write this equation in the form of this. That means y double dash minus 2 divide the whole equation by x square, okay. So 2 into x plus 1 by x into y dash plus 2 into x plus 1 by x square into y, this is equal to 0, okay. So this is the standard form of this type, okay. Now we know that means what, the value of p, this is equal to minus 2 into x plus 1 by x, and q equal to 2 into x plus 1 by x square, okay. Now we know some standard forms to get the solutions of second order homogeneous ODE with variable coefficient. What are the standard forms? No, number one is if p plus xq equal to 0, that means solution is of the form what, y equal to x, okay. Number two is, this is just recalling, okay. So if 2 plus 2px plus qx square, this is equal to 0, then solution is of the form y equal to x square. Number 3 is what, if 1 plus p plus q, this is equal to 0, then solution is of the form what, y equal to exponential x. If 1 minus p plus q equal to 0, then the solution is of the form y equal to e to the power minus x or exponential minus x, okay. If 5, if m square plus mp plus q, this is equal to 0, then the solution is of the form y equal to e to the power mx, okay, or m is any integer, okay. So this is, or integer or rational number also, it can be rational number, okay. So this is the standard forms. Now if we check whether any of the standard form for these equations satisfied or not, okay. So if we check, then we get suppose check first at 1. Okay, so p plus x cube, that means p means here minus 2 into x plus 1 by x plus x into q means 2 into x plus 1 by x square, that means x cancel, which is equal to 0. Okay, so p plus x q equal to 0 means y equal to x is the solution. Okay, so this implies y equal to x is the solution of this given differential equation. Okay, and since this is a solution and this is also a polynomial, so that means an order of the polynomial is 1, that is this is a linear polynomial. Okay, so that means the required answer which we required, the degree of the polynomial is clearly 1. Okay, this is from this we can easily say that the degree of the polynomial is 1. Okay, so here A is the correct answer. Okay, now go to the next question. The next question says that what, let fxy equal to f of xy, this is equal to y plus x into 1 minus x square minus y square minus x plus y into 1 minus x square minus y square. Okay, this is fxy, and consider the ODE x dot y dot equal to fxy, f of xy x dot y dot with the initial condition IC is given x0 y0, this is equal to 0 and half. Okay, which of the following statements are true? Here 4 statements are given, x square t y square t related. So how can we solve this question? First, since x dot equal to fxy, that means, and this is the pair, that means x dot equal to dx dt equal to the first one, y plus x into 1 minus x square minus y square, and y dot, this is equal to dy dt, this is equal to minus x plus y into 1 minus x square minus y square. Okay, so this is the given dx dt. Now we have to solve the system. To solve the system, how can we solve? This is not in generally solvable. Okay, so we try to solve in a different way. Okay, first we make a linear combination, a combination with this help of these two terms. Okay, suppose if we write x dx dt plus y dy dt, then this gives xy plus x square into 1 minus x square minus y square minus, this is multiplied by y, so minus xy plus y square into 1 minus x square plus minus y square. Okay, so these two terms gives cancel, so x square plus y square into 1 minus x square minus y square. Okay, so these are the general term. Now let us suppose x square plus y square, this is equal to u and another variable. Okay, so this gives 2x dx dt plus 2y dy dt. Okay, 2x dy dt plus 2y dy dt, this is equal to what, du dt. Okay, now if we multiply this by 2 and then put this value, we get, so we get du dt, this is equal to multiplied by 2, this is equal to 2 into x square plus y square means u. Okay, so 2 into u into and 1 minus u. Okay, this gives du by u into 1 minus u is equal to 2 integration dt plus constant. This is the term. So minus the log c. Okay, so this implies 1 by u plus 1 by 1 minus u integration du partial fraction is equal to 2t plus minus log c. Okay, so this gives log u minus log of 1 minus u minus log c, this is equal to 2t. This gives u by c into 1 minus u is equal to exponential 2t, and from this we get u by 1 minus u, this is equal to c to the power 2t. Okay, now This gives, so if we put t equal to 0 in this equation, so we get, if we put t equal to 0 in this equation, then we get x square 0 plus y square 0 equal to u0. Okay, now put the value here, and x square x0 means 0 and half, so this implies 0 square plus half square equal to u0. So that means u0 is equal to 1 by 4. Now put this here. Okay, so if we apply u0 equal to 1 by 4, so 1 by 4 by 1 minus 1 by 4, this is equal to c into e to the power 2t, 0 means 1. This gives c equal to 1 by 4 by 3 by 4, this is equal to 1 by 3. So the value of c is 1 by 3. Okay, now the value of c is 1 by 3. Okay, now from this we get u by 1 minus u is equal to 1 by 3 e to the power 2t. This implies 3u is equal to e to the power 2t minus u e to the power 2t. This implies 3 plus e to the power 2t into u, this is equal to e to the power 2t. That means ut, this is equal to e to the power 2t by 3 plus e to the power 2t. This is equal to 1 by, if we multiply both numerator and denominator by e to the power minus 2t, this gives e to the power minus 2t plus 1. So this is the solution of the given differential equation. Now what ut means, what ut means x square t plus y square t, this is equal to 1 by 3 to the power minus 2t plus 1. Okay, now option 1 says that x square t plus y square t tends to infinity and tends to infinity, but as t tends to infinity, this term goes to what, 1. Okay, and that means the option 1 it says that it is tends to infinity, which is not correct. That means option A is false, option A false. Option B says that it goes to 0, which is also false. Option C says that tends to remains bounded, and yes, as t tends to infinity, since this is clearly 1, that means this function is clearly bounded. Okay, so C is correct option, and D says that it tends to 1 and t tends to infinity, that means it is clearly correct from here. Okay, so this is the question. Okay, so now go to the next question. So the next question says that let x and y continuously differentiable function on 0 infinity and satisfy the respective IVP. The IVPs are dx dt, this is equal to dx dt plus sin t minus 1 into x, this is equal to log of 1 plus t with x0 equal to 1, and the second one is dy dt plus sin t minus 1, this is equal to into into y, this is equal to t, where y0 this is equal to 2. Okay, so these two are the equation. Define zt equal to, where zt equal to xt minus yt. Then 4 options are given, which statements are true, z less equal to 1 and so on regarding. So first we try to solve these questions. Okay, this equation. Okay, so dx dt plus px equal to q, so we have first find the integrating factor to solve. So exponential integration sin t minus 1 dt, this is equal to exponential minus of cos t minus 1, this is equal to exponential minus t plus cos t. Okay, so this is the integrating factor. Now this implies integrating d of x exponential minus t plus cos t, this is equal to integration exponential minus of t plus cos t log of 1 plus t dt plus suppose constant of integration is equal to a. Okay, this implies x e to the power minus t plus cos t, this is equal to integration, this is a big integration, this term we put it as it is in the above state. Okay, above step. Okay, t plus cos t to log of 1 plus t dt plus a. Okay, so this implies x t, this is equal to multiplied exponential this side, exponential t plus cos t into a plus integration exponential minus t plus cos t log of 1 plus t dt. Okay, this. Now applying x0 equal to 1. Okay, applying x0 equal to 1, this gives 1 equal to this terms exponential only e, 0 plus 1 into a plus exponential log of 1 plus 0 means log 1. Okay, log 1's value 0, that means this whole terms goes to 0. Okay, that means a equal to 1 by e. Okay, that means from here we get xt, this is equal to exponential t plus cos t into 1 by e plus integration of exponential minus t plus cos t log of 1 plus t into dt. Okay, now okay, this is the xt. Okay, now if we solve this yt same as it is, this is the solution again. So yt equal to integration, this term is again the integrating factor, so t plus cos t, I write it as this line. Okay, so t plus cos t integrating factor suppose b plus exponential minus of t plus cos t into here the terms is t. Okay, so this is t into dt. Okay, so this is the yt term, and if we apply when y0 equal to 2, this gives 2 equal to exponential, it is exponential and b, and this term goes to t here, that means 0, so plus 0, that means simply gives b equal to 2 by e. Okay, now here the question in the question is given that xt equal to what, minus 1 xt zt, this is equal to yt minus xt, sorry, this is yt minus xt. Okay, this is yt minus xt. Okay, z equal to yt minus xt. Now if we solve this one, so and here from this yt equal to exponential t plus cos t, b means 2 by e plus exponential minus t plus cos t into t dt. Now zt equal to yt minus xt gives, so this is yt and this is xt. Okay, so take common exponential, this is equal to exponential t plus cos t common. Now yt means 2 by e minus 1 by e, that means this gives 1 by e simply, and this term minus this term, and here in the inside of the integration exponential minus of t plus cos t common. Okay, so take common exponential minus of t plus cos t, and here simply t minus log of 1 plus t, so this means t minus log of 1 plus t dt. Okay, so dt term. Okay, now here the options are including z1 and z2, so first find z1. Okay, so z of 1, now we first erase this part. Okay, this is not necessary now. So now we calculate z at 1, so this is equal to exponential 1 plus cos 1 into 1 by e plus integration of exponential minus of 1 plus cos 1 into 1 minus log of 2, okay, into dt, and this is simply t. Okay, so this is, if we multiply this term and these two term, then this two term gives E cancels, so exponential of cos 1 into what? Exponential cos 1 plus these two terms are constant, so this is exponential into exponential cos 1, and this simply integration of dt. Okay, and this is, oh, these three terms gives cancelled. Okay, so this is simply outside of the integration is these two terms cancel. So this term is simply 1 minus log 2. Okay, and integration of dt. So this is the value of z1. Okay, now we find the value of z2. So z2 equal to exponential 2 plus cos 2 into 1 by e plus integration e to the power minus of 2 plus cos 2 into 2 minus log of 3. Okay, to dt, integration of dt. So this is equal to, this two term gives e 1 plus cos 2, and if we this term from outside of the integration, so sorry, this is the integration term dt. Okay, so this term, these two terms gets cancelled, and simply plus 2 minus log 3 into simply integration dt. Okay, so these two terms. Now what? Obviously this term exponential power cos 1 means exponential e का जो value था 2.73 nearly equal to. Okay, so this power cos of 1, that means this value is obviously greater than 1, and this is also positive term, and this t since t belongs to 0 infinity. See here given that t belongs to 0 infinity, that means what? That means this integration dt obviously greater than 0 or greater equal to 0, you can say. Okay, and the value of 1 minus log t is also greater than 0, and this term exponential is obviously greater than 1. Okay, so this means this term z of 1 obviously greater than 1, and now this term also greater than 0, this term, since this interval given, and 2 minus log 3 also greater than 0, and this term exponential 1 plus cos 2, this is obviously greater than, so exponential 1, so compare this term and this term. Okay, we get what? Since this term is a simply positive quantity, okay, and this term what? This term is greater than this term, no? So exponential, since here one exponential is extra, so exponential 1 plus cos 2, which is clearly greater than exponential cos 1, na? Okay, is this clear? This term here, since here one exponential term is extra, and since exponential is an increasing function, that means this is greater than this, so that means we can say z2 is greater than z1. Okay, so these two conclusions can be drawn easily. Okay, so this is a analytical questions. Okay, so our answer is z1 is greater than 1, z2 and it is equal to z1. That means here option B and C are correct. Okay, option B and C are clearly correct. Okay, now another one question is here, just a minute. The next question is, for lambda belongs to R, consider the system of ODEs x1 dot, this is equal to x1 plus 2x2 plus 2x3. Okay, and x2 dot, this is equal to 2x2 plus x3. Okay, and x3 dot, this is equal to minus x3 plus 2x2 plus lambda into x3. Lambda belongs to R. Okay, if xt equal to xt, this is equal to alpha t exponential 2t for some alpha is a solution of the system, then what is the value of lambda you have to find. So the system, we can write the system as x1 x dot is equal to a x. Okay, so that means x1 dot x2 dot x3 dot, this is equal to a matrix is 1 2 2 0 2 1 and 0 2 lambda minus 1. So this is the matrix and x1 x2 x3. Okay, so that means the coefficient matrix M is this one. Okay, and here it is given that xt equal to alpha t to the power 2t. Now we know that this is the solution and the solution is of the form must be this 2 is an eigenvalue of this coefficient matrix. So this 2 is an eigenvalue of the coefficient matrix, suppose A. Okay, so the coefficient matrix suppose A. Okay, now if we this not lambda is the and this 2 is not same. Okay, this is another quantity. Now for this eigenvalue, that means for this one the system must be consistent, and for one eigenvalue this 2 the system has an unique solution, and for unique solution of a system we must get what? Unique solution means trivial solutions which gives this determinant is equal to 0. Okay, so that means if we calculate 2 1 2 2 0 2 1 and 0 2 lambda minus 1 is equal to 0. If we calculate this, then we get 1 into 2 into lambda minus 1 minus 2 is equal to 0. That means 2 lambda minus 2 equal to 0. That means 2 lambda equal to 4. That means lambda equal to 2. So the value of this lambda is equal to 2. Okay, so this is our answer. The lambda value of lambda equal to 2. Which option? That option 1 is correct here. Okay, so this is the questions in this video. If the video is helpful, then please give a like to this video, share with your friends and subscribe the channel. Okay, so thank you friends. See you again in the next video. Thank you.